Question number 4. Show that the given equations 5x plus 3y plus 7z equal to 4, 3x plus 26y plus 2z equal to 9, and 7x plus 2y plus 10z is equal to 5 are consistent and solved by rank method. Show that they are consistent. It should follow any one of the first two property. If it is consistent, you should have a solution. If solution exists, it will happen in two different way. One is a unique solution or an infinitely many solution. Now, the corresponding matrix equation is coefficient matrix, variable matrix, and equal to constant matrix. The coefficient matrix is 5, 3, 7, 3, 26, 2, and 7, 2, 10. The variable matrix is always taken as x, y, z. The constant matrix 4 in the first equation, 9 in the second equation, and 5 in the third equation. Now we have to form an augmented matrix. Augmented matrix AB is nothing but combination of matrix A and B. A is 5, 3, 7, 3, 26, 2, 7, 2, 10, and B is 4, 9, 5. This is augmented matrix AB. Now, we should form the given matrix as an equivalent matrix in the form of echelon or echelon form. For that, here the entry is 7. Here we have 5. Multiply the first row by 7 and the third row by 5. Subtract. You can easily get this entry as 0. That is a better way. Else, you should divide all the entries in the first row by 5. Then make this entry as 1. Again we multiply the first row by 7. You can subtract. That will be some lengthy process, because if fractions appears, then the further applications will be difficult. So just multiply R1 by 7, it will be 35. Then R3 by 5, this element has 45. Then we subtract 35 minus 35 becomes 0. So it is very easy to form another equivalent matrix. This R3 tends to, we are forming an equivalent matrix. In this R3 become 5R3. Multiply R3 by 5, it will be 35. And multiply R1 by 7, it is 35. Subtract these two. You will form we can form a new row R3. For that, I am processing here 5R3, 35, 10, 50, 25. Multiplied R3 by 5. Then multiply R1 by 7, 35, 21, 35, 49, here 28. Subtracting first entry, 35 minus 35, 0. Now subtract. After subtracting we have 0, minus 11, 1, minus 3 as entries. So 0, write it in the third row, 0, minus 11, 1, minus 3. Now we should give priority to make this entry as 0 in the second row, first entry. For that, multiply first row by 3. This 3 with the first row, that is 15. And this 5 with the second row, that is 15. Now 15 minus 15 becomes 0. You need not to focus on any other element. Always focus the first element, okay? First element. R2, therefore, R2 tends to 5R2 minus 3R1 minus 3R1. Here the iteration happen here. I am processing here 5R2. 5R2 means multiply R2 by 5. 15, 26 into 5, 130. Then 2 with the 5, 10. 9 with the 5, 45. Next, multiply the first row by 3. That means 15, again 9, then 21, here 12. Subtract 15 minus 15, 0. 130 minus 9, 121. 10 minus 21, minus 11. 45 minus 12, 33. Now we have 0, 121, minus 11, 33 as the answer. Write these entries in the second row. That is 0, 121, minus 11, 33. Then 5, 3, 7, 4. No change in the first row. You can keep the same as it is in the first matrix. Right. Now look at the last two rows. They are proportional. Multiply by minus 11. Minus 11 into minus 11, 121. 1 into minus 11, minus 11. Minus 3 into minus 11, 33. So these two are proportional. So we can reduce the second row by 3. Divide the second row by 3. It will be reduced. That will be equal to I am going to write here. The another equivalent matrix is 0, minus 11, 1, minus 3. There is no change in it. R2 tends to R2 divided by minus 11. R11. R2 divided by 11. Divide R2 by 11. 0 divided by 11, 0. 121 divided by 11, 11. And here minus 1. And here 3. The first row, no change. 5, 3, 7, 4. Now look at the rows. They are proportional. Just multiply by minus 1, you will get the third row. So just adding these two rows, all the entries in the last row will become 0. That means the next equivalent matrix is R3 tends to R3 plus R2. Adding these two and writing in R3, 0, 0, 0, 0. Now all the entries in the third row are 0. Now we are moving to form this 11 as 0. To make this 11 as 0, we should multiply this first row by 11 and the second row by 33 and we should subtract. Suppose doing that, this 0 entry become non-zero. So you can stop the process and this may be this indicating that the problem is getting over. So now write the second row as it is in the above matrix, then write the first row 5, 3, 7, 4. Now this is the required last equivalent matrix. The last equivalent matrix is in echelon form and also we cannot push it further. So we can stop the process here and we can conclude the answer. Now find the rank of A in the last equivalent matrix. The last equivalent matrix consists of only two non-zero rows. Therefore rank of A equal to 2 and rank of AB. Now adding the fourth column with the matrix and also finding the rank. Now here also one zero row and two non-zero rows, which implies rank of AB is also 2. Here rank of A equal to rank of AB equal to 2. We can conclude the answer. Rank of A equal to rank of AB equal to 2. That is less than 3. That means less than 3. There are 3 unknowns x, y, z. The rank is 2. That is less than the unknowns. Number of unknowns. Less than 3. That means less than number of unknowns. Less than number of unknowns. Less than 3 it is enough, it seems. Less than 3. Therefore, the system is consistent and it has infinitely many solutions. Now, rank of A equal to 2, rank of AB equal to 2. Rank of A equal to rank of AB equal to 2 less than 3. That means less than number of unknowns. Therefore, the system of given equations is consistent and it has infinitely many solutions. To find these infinitely many solutions, we should convert the last equivalent matrix into matrix equation, that is 5, 3, 7, 0, 11, minus 1, 0, 0, 0 into the corresponding variable matrix x, y, z, that is equal to the constant matrix. This last column denotes the constant matrix 4, 3, 0. The last column denotes the constant matrix. Now framing the equation, forming equation from this matrix equation, we will get 5x plus 3y, 5 into x plus 3 into y plus 7 into z, plus 7 is z equal to 4. Let it be equation 1. And second one, 0x we can omit, 11y minus 1 is z equal to 3. Let it be equation number 2. The third one is 0x plus 0y plus 0z. No equation will be formed. Therefore, third equation will not be formed. By using these two equations, we should solve and find x, y, z values. We have two equations, but number of unknowns is 3. Whenever the number of unknowns is greater than the number of equations, the system of equations follows infinitely many solutions. We have two equations but 3 unknowns appears. In this case, we can have infinitely many solutions. Already we have discussed it is infinitely many solution. So how to find this infinitely many solution? In this case, there are infinite solutions. We should assume either for x or y for z a real number as a infinite, as a solution from the infinite numbers. Let to solve, assume z equal to k where k belongs to R. Assume one solution k as a solution from this equation to these equations that is taken from the real number, and substitute in the second equation. 2 implies 11y minus k equal to 3, then 11y equal to 3 plus k, which implies y equal to 3 plus k by 11. This is y value, and substituting the z equal to k and y equal to 3 plus k by 11 in the first equation, we will get the value of x in terms of k. Here look at the answers. Z in terms of k, y is also in terms of k. We can find x also in terms of k, which implies substitute z equal to k and y equal to 3 plus k by 11 in 1, which implies 5x plus 3 into y. Instead y substitute 3 plus k by 11 and plus 7 z. 7 into z values k, 7k equal to 4. Multiply 3. continued here. 5x plus 3 into 3 plus k by 11 plus 7k equal to 4. Multiply 3 inside. 9 plus 3k by 11 plus 7k equal to 4. Now bring these two terms right side. 4 minus 7k minus of 9 plus 3k by 11. Now bring minus inside. Minus 9 minus 3k. Taking LCM. 44 minus 77k minus 9 minus 3k whole divided by 11. Simplify this, we can get 5x is equal to 35 minus 80k by 11. Dividing by 5, this one become 1x or x. Here 7 minus 16k by 11. So x is equal to 7 minus 16k by 11. And the solution is, already we have found y and z. Now x is equal to 7 minus 16k by 11. Therefore, solution x comma y comma z equal to 7 minus 16k by 11, 3 plus k by 11, comma k, where k belongs to R.